Hello everyone, this is Vashita. I am studying 5th semester of Computer Science and Engineering. This video is about software engineering. So what is software engineering? Software engineering is a process of systematically building, maintaining, managing the software. In today's world, software is everywhere, from the apps on your phone to the medical devices. To meet the growing needs and challenges, software must be built carefully and systematically, just like the bridges or the machines. So, coming to the definition of software engineering, first broad definition is software engineering is the use of sound engineering principles to build the reliable, efficient software economically. This definition means like software sound principles like use proven particles practices like design, planning, and testing. Economically is nothing but build the software without wasting time or money. Reliable and efficient is for software should be work correctly and well run well as many for many devices. And also, IEEE definition for a software engineering is a systematic, disciplined approach to developing, operating, and maintaining the software, and is a software engineering. And software engineering is also the study of how to apply the engineering to the software. This definition emphasizes that the discipline is necessary to maintain or manage the software projects, but the process must be also be a flexible to fit the different teams. So coming to the realities of the software engineering, we have to understand the problem before building the solution, and then design is critical, and high quality is essential for software engineering, and software must be maintainable. By understanding the problem before building the solution, is will also help the stakeholders with different opinions, like so that they can gather many input early to provide the solution for the different problems later. Coming to the design is critical because in the past, software was simple enough for a one person to build, but now large teams work on this complex systems such as electronics and medical devices. Careful designs ensures that all the part works well together and helps to prevent the mistakes later. Coming to the high quality, which is very essential for software engineering because we depend on the software for important tasks like business decisions and controlling the machines. If the software fails, it can cause minor inconvenience or the disasters. That's why the software quality should is a crucial. Coming to the software should be maintainable because good software lasts long for a long time. As the people use it, they'll ask for the updates and the improvements, and this designed software is easier to maintain and adopt the new requirements. Coming to the layers of the software engineering, we have three layers of software engineering, that is process, methods, and tool layer. The first one is process layer, which is a foundation of the software engineering. This software process is a framework that guides the development of the software. It ensures the projects are well managed, quality is controlled, and changes are handled properly. Coming to the second layer, that is a method layer, the how to layer, which provides the detailed steps for communicating with the stakeholders, analyzing the requirements, designing the model of the software, building and testing of the software, and supporting and maintaining the system after the release. These are the steps for methods layer. And coming to the tools layer, that is the last, which is also known as automation. The software engineering tools like programming environment or testing software helps the automate parts of the processes. When the tools are integrated to the work, this is also called as CASE, which is nothing but computer aided software engineering. Now let's know about the software myths. Software myths are common but incorrect beliefs about building the software. These myths can cause a problem because they sound reasonable, but feel intuitive, and are often spread by the experienced people. Even though many professionals know these beliefs are false, they still persisted. Let's break down them into three categories, that is management myths, customer myths, and practitioner myths. So what are management myths? These are the false beliefs held by the manager who need to meet the deadlines, control budgets, and improve the software qualities. There are some myths and the realities. The first myth is we have a standard book that enough for a building software. But the reality is, having a book of rules isn't enough. But because the people might not follow it, and also the content may be outdated or incomplete. So we can say that the standard books are not enough for building a software. There are many myths and realities which shows us that myths are always not the reality. These are some examples. And coming to the customer myths, we can know that customers often believe incorrect things about the software project, which can lead to the confusion and disappointments. Some of the myths are that we don't need all the requirements now. Just start the coding, and we'll figure out the details later. But the reality is, vague objective leads to the problems, and it's crucial to understand the requirements clearly, even if not everything is known at the start. And also, the another myth says that it's easy to change a software requirements since software is flexible. But the reality is, changes early on are manageable, but as the development processes progresses, changes become more expensive and complicated. Coming to the practitioner myths, these are the myths believed by the software developers and the engineers, often due to old habits from early programming days. There are many myths in practitioner myths. Some of them are, once the program works, our job is done. But the reality is, most effort is spent maintaining and improving the software after it's first delivered, or up to 80% of the total work. And also, there is another myth that says that the only thing that matters is the working program. But the reality is, the successful software project also includes the models, documentation, and the plans. These elements helps to manage the project and maintain the software over time. So that was about the software engineering. Thank you for watching this video.